Hey guys, so we're going to start Unit 8. We're going to talk about first, Objective 35 is going to be surface area, and then we'll also talk about 36 in the next video, which will be volume. Alright, so talk about surface area. Alright, first things first, we want to make sure we just remind ourselves, a good old order of operations. So PEMDAS, make sure we remember everything stands for. So P, parentheses first. Then E, right? Next we have our exponents. So those always come next. All right, then here's the deal, is then we have M multiplication slash division. So this is our multiplication slash division. Those can be done in either order, but this parentheses has to be first, exponents has to be second, then it's your choice. This is 3 or 4, and then of course addition, subtraction. Okay, this can be done as 5 or 6, but these two got to be first. Then you kind of have your choice whether you want to do multiplication or division, but always has to come before addition or subtraction. So let's just do a little warming up here. So this says parentheses 3 minus 1 to the third power divided by 4. Well, certainly we have parentheses, so we got to do those first. We know that for sure. So we got to do 3 minus 1. So that's going to be 2 to the third power divided by 4. Next, we got to do exponents. So 2 to the third power means 2 times itself 3 times. So 2 times 2 times 2, which is 8. Divided by 4, it's our only operation left. Boom, get 2. All right, let's go to the second one. 3 plus 6 to the second power times 2, or 3 plus 6 squared times 2. Well, got to do this first, exponents, because there's no parentheses. So 6 squared is 36. 3 plus 36 times 2. And then we have to do either multiplication or division. So we got to do those. So 3 plus 36 times 2, which is 72, gives us, boom, 75. All right, so a little order of operations. This is going to be important when we're doing surface area, as which we got to do first. All right, so let's talk about a couple things here. This idea of area versus volume. If you guys want on your paper, you can draw yourself a little Venn diagram here. Do area on the left, volume on the right. Area, it's 2D, two-dimensional, right? It's like a flat surface. If you want to find the area of a carpet or a rug, it's lying flat on the floor. You just want to see how much space it takes up. Volume, of course, is three-dimensional, right? When you're filling in like the space of something, right? What's the volume that the cylinder can hold if you're in science class, right? So how much water can it actually hold? It takes up three-dimensional space. Okay. Area, of course, this has to do with shapes, meaning things that are flat on a piece of paper. And volume has to do with solids, meaning things that you could actually hold, that they have three-dimensional weight to them. So like a box, how much stuff can you fit in an actual shoe box? That's three-dimensional. That's called a solid. How much area of a rectangle, that's something drawn on a piece of paper, that's a shape. Okay? We always want to use our units squared, like centimeters or inches. And then for volume, we always want to use our units cubed. We call it, right? To the third power, we call it cubed. So we always want to use it cubic units versus square units. And where they overlap is that they really both have to do that they determine the space that something takes up, right? Either flat on a piece of paper, like a rectangle or a circle or a triangle, or like a solid, the volume of a cylinder or a prism or something like that. So they both determine the space. Okay, so let's build on that. A couple things that we need to know is that we need to know all these different parts of a solid. Okay, so a solid is a 3D shape. A face is going to be the flat side of a solid. So think about a cereal box. Think about a Cheerios box. A face is going to be that, boom, that front side. That whole Cheerios logo with the, whatever, the yellow, the pictures on it. Okay, that's called a face. So a face is something that you could kind of run your hand across. It's like the advertising right on that front side of the cereal box. An edge, certainly, is where two faces meet, right? So this right here is an edge, and it's exactly like it sounds, right? You run your finger along the edge of a box. It's that long strip. You can feel it, so that's an edge where the two meet. And then the vertex is like a point somewhere. So think about looking at your cereal box. Put your hand on the very top front corner. It's pointy, right? Kind of pokes you. That's a nice sharp vertex. So, right, this right here, that nice pointy place where edges meet. So that's going to be our vertex. Yeah, so always think back to something like a cereal box. That's kind of like the best example that we can use. Okay, so volume and surface area. And what I want you to think about is that surface area, we're going to call it SA. Surface area has to do with the wrapping paper, and volume has to do with what is inside. So surface area has to do with the wrapping paper, and volume is what you can fit on the inside. All right, so let's kind of move on here with surface area. So let's define surface area. So we'll say surface area is, whoa, sorry about that. Let's see, surface area is the total area of all the faces of a solid, right? It's like, how much wrapping paper do you need to cover the front of the cereal box, the back, the side with the nutritional facts, the other side, the top with the flap, and the bottom? If you were to wrap a cereal box but not have any excess left over, that's what we want to think about surface area. Of course, volume is how much can fill, right? Volume is how much stuff can fill that cereal box. If you were to pack Cheerios all the way from the bottom, you pour them in all the way to the top. Imagine there wasn't that plastic bag on the inside, right? You filled Cheerios all the way to the top. How much space could you fill in? So volume is how much you can fill. Surface area is all the faces on the outside of that box. All right, let's do some problems here. But first, we need a very, very special formula. So this needs to go on your note sheet 100%. So SA means surface area. Surface area is equal to 2 times the length times the width plus 2 times the length times the height plus 2 times the width times the height. So L is length, W is width, H is height. Now, I'm going to just draw this very, very bad looking Cheerios box. Okay, and here's why. Here, I'm going to talk to you a little bit about the formula. Ready? Here's why. Let's assume that we found the length and the width of this front side of the Cheerios box. Boom. Guess what, guys? There's another side directly on the back that matches the front. So there's the front side and the other, so that's where the 2 comes from. There's 2 sides that have the logo on the front and all the games and whatever stuff else they put on the back. Okay, then in a different color, let's say we found the area of the side flap that has the nutritional facts. And that is, let's say, the height times the length times the height, right? Well, guess what? On the other side of the box, there's another flap that's exactly repeated. So it's 2 times that. And then, of course, the top and the bottom, let's maybe use pink or something. The top where you open it and the bottom flap again, they repeat. They're a mirror copy of each other. They're an exact copy of each other, so there's always 2. So that's where the 2's come from. 2 times length times width. Add that to 2 times the length times the height. Add that to 2 times the width times the height. And we add up all the faces. That's how much covers the entire box. That's what we'll call surface area. Okay, so here's the great thing, guys. You can choose whatever length, whatever is width, and whatever is height. You just have to make sure that you assign and don't repeat any of the length, width, or height. It's totally up to you. Okay, so this is called a rectangular prism. A box is called a prism. That's our fancy name for it, right? It's a box, but we call it a prism. A prism is a 3-dimensional solid. This is a rectangular prism. Okay, so here's our formula. But before we use our formula, we need 3 things. We need a length, we need a width, and we need a height. I usually just make length the longest. So like, let's make the length 6. Let's make the width 3, and then the box looks like it's about 2 feet tall. So I usually say that's height. So length, width, and height. Get your dimensions, use the formula. It's that simple. Let's do it. Surface area equals 2 times the length. Let me just write it out one time first. 2 times the length times the width plus 2 times the length times the height plus 2 times the width times the height. And now we're just going to plug in all of our dimensions. Here we go. 2 times the length, which is 6, times the width is 3. 2 times the length, which is 6, times the height, which is 2. Plus 2 times the width, which is 3, times the height, which is 2. That's all we're doing. Plugging it in. Love it. Let me get rid of this thing down here. All right, so we know, guys, order of operations, you got to do your multiplying before you start adding. So 2 times 6 times 3, use your calculator. 2 times 6 is 12. 12 times 3, 36. Plus 2 times 6 times 2. 2 times 6 is 12. Times 2, 24. Plus 2 times 3 times 2. 2 times 3 is 6. Times 2 is 12. Add them all up. Surface area is 36 plus 24 plus 12. Looks like 60 plus 12. 72. What's our units? Feet. And we're talking about surface area. So it's feet squared. We'll keep going with it. Just think about your formula. Think about, okay, I need 2 of the Cheerios front and the back. There's my 2. I need 2 of the sides of the box with the nutrition facts on the other side. Boom, there's my other 2. And I need the top flap and the bottom. There's my other 2. Length times width, length times height, width times height. Boom, here we go. Okay, find the surface area. Like I said, guys, here we go. Length, let's make the length 12. Let's make the width 6. Let's make the height 5. Go to the formula and rock it out. 2 times length times width plus 2 times length times height plus 2 times width times height. Perfect. Let's plug in what we know. The length is 12 and the width is 6. The length is 12 and the height is 5. And the width is 6 and the height is 5. And as you can see, the length, the width, and the height are all repeated 2 times each. So if you see a 12 and 12 has popped up 3 times, you did something wrong. You got to make sure you stick with your length, your width, and your height. All right, so we need to multiply it first. So 2 times 12 times 6. I'm using a calculator. Use your phone, whatever. Use the computer. Use your brain. It's all good. 2 times 12 times 5 is 120. And 2 times 6 times 5 is 60. To get your total surface area, you add them all up. 144 plus 120 plus 60. 324. Didn't have any units, so we'll say units squared. Number 3, calculate the surface area. Love it. Let's go and do it. Length, width, height. Actually, you know what? I'm going to move those over here. No big deal. I usually always pick the longest one for my length, guys. It doesn't matter as long as you just pick it and stay consistent. So let's make the length 9, the width is 5, and the height is 1.7. Because it does kind of look like that's kind of the height, how tall the box is. All right, to the formula. 2 times length times width plus 2 times length times height plus 2 times width times height. Love it. Length is 9, width is 5. Length is 9, height is 1.7. Width is 5, height is 1.7. I used 9 twice, good. I used 5 twice, good. I used 1.7 twice, boom. Order of operations, I'm using my calculator. Got to do all the multiplying first. 2 times 9 times 5 is 90. 2 times 9 times 1.7 is 30.6. 2 times 5 times 1.7 is 17. We got our 3 values. Add them all up. 90 plus 30.6 plus 17. 137.6 units squared because it is surface area. Bada bang, bada boom. Keep rocking, keep rocking, keep rocking and rolling. Okay, Billy. When Billy opens and lays a cereal box out flat, he sees that the top and the bottom each measure 3 inches by 9 inches. The sides measure 3 inches by 11 inches. And the front and the back each measure 9 by 11. What is the surface area? Well, Billy, we're going to help you out here. We need a length, we need a width, and we need a height. Guys, hopefully we notice, okay? 3 by 9, 3 by 11, and then 9 by 11. So there's only 3 unique measurements. The 3, the 11, and the 9. They all happen twice. Just pick whatever you want. I usually go largest to smallest. Length, width, and height are just words. They just represent a measurement. You pick whichever one you want as long as you only assign 1 to the length, 1 to the width, and 1 to the height. So let's make our length 11. Let's make our width 9. And let's make our height 3. Good. We got an 11. We got a 9. We got a 3. Let's go and do it. Surface area, 2 times length times width plus 2 times length times height plus 2 times width times height. Here we go, using the formula. Length is 11, width is 9. Length is 11, height is 3. Width is 9, height is 3. Love it. Order of operations, 2 times 11 times 9, 198. 2 times 11 times 3, 66. 2 times 9 times 3, 54. Add them all up. Plus 66 plus 54. That cereal box would require 318 square inches to cover it, head to toe. All right, here we go. I think we got one more example here. Could be 2. I don't know. But we at least got another one. Calculate the surface area of a rectangular solid that is 8 inches long, 7 inches wide, and 13 inches high. And guys, here's a perfect example. I always use the strategy where if they don't tell you the length, the width, and the height, I always go with the biggest down to the smallest. But sometimes we've all seen, things that are a lot taller than they are wide or a lot longer than they are tall. So whatever, just go by what the problem tells you. It says it's 8 inches long. That's going to be the length. So let's let the length be 8. It's 7 inches wide, so that's our width. And it's 13 inches high, so that's our height. Surface area. 2 times length times width plus 2 times length times height plus 2 times width times height. A lot of formulas here, people. I'm telling you. Unit 8 is the unit of the formulas. So many formulas. And you just gotta use them. You just gotta use them. There's no other way around it. This is where geometry just gets so formula based. But you know what? We rock out with it. Here we go. 2 times 8 times 7. That's 112. 2 times 8 times 13. That's 208. 2 times 7 times 13. 182. We're doing our order of operations. We are doing our multiplying before we are adding. Now we add them all up. 502 are units, inches squared. Look at that, 35 in the books. Get to it, accelerated math. Do what we do best, and I'll see you guys in a second for 36.